1 point what?
5?
1.5. How could we actually check if it really
We
did?
put 0 in.
What would we have to do?
Put 0 in the thing.
No. Is it an improper integral?
Oh, get a limit.
It would be an improper integral, right? From where to where?
0 to 1.
From 0 to 1, right? Because we're trying to find out what happens as I get close to 0, that vertical asymptote. So it would be really like if we were solving this guy, right? And in order to solve him, we would have to write a limit. So we'd have to say the limit as a approached 0 from the right, right? Of the integral from a to 1 of him. So how are you supposed to know if you get a problem like this that he has a vertical asymptote somewhere? How do you have to think of him?
Think of it as 1 over x to 1 over q.
Right, 1 over the cube root of x, right? And then you can find out that his vertical asymptote is at 0, right? So you know that he is improper. And work with him from there. And if we work this guy out, what do you think our final answer is going to be?
Conversion.
1.5. It should end up being 1.5. Do you want to work them out or you trust me?
I trust
Yes.
you.
You trust me?
I trust you.
Now, let's look at him the way we looked at him before. So, what would you say the integral from 0 to infinity of 1 over x to the 1/3 would be, or would do?
No, converges from 1.5.
What would he do?
That diverges.
Oh, that diverges, right?
This guy diverges?
Yes.
Why does he diverge?
His power is less than 1.
P is less than or equal.
P equals 1/3, which is less than or equal to 1, right? So he diverges. Oh, how weird. So he diverges when I go that way, but he converges when I go this way. You think that'll always happen?
Maybe.
No.
No, it won't.
Perhaps.
What if he converges when you go to infinity? Do you think it's going to diverge as I go to
Maybe.
0?
It depends.
I think so.
Think so?
Oh, God.
So give me something that converges as I go to infinity.
1 over
x.
1 over x to 1/3.
1 over x to the 1/3? No, that doesn't converge as I go to
Just
infinity.
kidding.
1 over x squared.
1 over x squared, okay. So we know for sure that 1 over x squared converges as I go to infinity,
Oh, converge.
right? Because p is greater than
1.
1. So let's see if he diverges as we go to 0, as I get closer and closer to 0. 1 over x squared we said, right?
Of course.
So what does 1 over x squared evaluated from 0.01 to 1 give us? We could also put him as x to the negative 2, right?
99?
Thank you. 99?
99?
Cool.
Wow.
Let's get closer to 0 because that's pretty far. 0.001. And let's do it like this. Maybe that'll be easier. Or if you already have it typed in, then just add another 0.
999.
999?
What?
It's
That's a pretty big jump. It looks like he's converging to 1,000, right?
No.
No.
No?
Diverging to
Infinity.
Are you sure?
No, positive.
Let's get closer.
Yeah. That's a
So if this one had 3 9s, how many 9s is this one gonna have?
It's gonna have a billion.
Oh, 4. It's not 4.
4?
4.
Correct.
Are you sure?
We're sure.
Oh, maybe that's like a number sense trick or something.
Oh,
Man.
oh my god.
He's
subliminally
Yeah, like,
teaching
oh,
us.
there's 4 9s, yeah.
Whoa!
Is that a number sense trick? And
Correct.
what is this one doing?
Every day.
It's diverge.
He's gonna diverge,
Yeah,
right?
happens every day.
To what?
Anyways.
Those numbers are getting pretty big pretty quickly.
He's going so fast.
So can we make that conclusion?
No.
That if the p series converges as I go to infinity, he's going to diverge as I approach 0.
Most likely.
More than mine.
And vice versa. If it diverges as I go to infinity, then he's going to converge as I go to 0. Okay, so that might be something good to know. Especially with questions that are just going to be diverges as an answer choice. You don't have to waste your time discovering that it diverges. If you can recognize that it's in the p series form. Does that make sense?
So when it diverges to infinity,
When it diverges to infinity, it converges to zero.
And if it diverges at zero, it converges to infinity.
Yeah,
Yes.
okay,
So 34?
cool. The only exception to that rule is which one?
It's 1 over.
1 over x, okay? 1 over x will diverge to infinity and diverge to zero, okay? He's the only exception to that rule. Everybody else will work. Cool? You wanna write that down or
Right, yes,
you're
please.
good?
No, please write it down.
Wanna write it down?
Yeah.
Okay, cool, let's write it down. Let's write it down.
What over x? Both of them are.
As you
As you can see, if you have a function of the form 1 over x to the p, which converges as x goes to infinity. So that means that the p has to be greater than 1, right?
We can't read.
Can't read? Oh, I'm sorry.
We can't.
It will, what?
It will diverge.
It will diverge as x approaches what?
Negative
Zero from the right.
From the right.
Okay, because it's gonna have what there?
A asymptote.
It's gonna have the, yeah, an infinite discontinuity or a vertical asymptote. Anything in this form is always gonna have a vertical asymptote at what?
Zero.
At 0. Cool?
Yeah.
Yeah?
Yeah.
So the, what is it? Is it the converse of that?
And vice
Inverse.
versa.
And vice versa?
Yeah.
Freaking god.
Freaking got him.
The only exception
It's the holy grail.
is what?
1 over
Whatever
x to the 1.
Is 1 over x, right? Which diverges in both directions. Cool?
What's in that? That's the parentheses, the first parentheses.
P greater than
Be
1.
greater than.
That's how you know it converges if x goes to infinity. Cool? That integral from 0 to 1 of 1 over x is known as the harmonic series.
Ooh, physics.
Remember that one? Hear that word, harmonic?
The
Harmonic series?
I guess.
The harmonic mean? Do you know how to find the harmonic mean?
Yes. 1 over
Comes
x squared plus 7.
Huh?
1 over x squared plus 7.
Interesting.
Thank you.
Alright, are we good?
Yes.
Yes? Or do we need to do the exploration and prove that these guy equals 1.5 and the other one?
Column work.
Goes
Column
infinity?
work. Column work.
No? You're good? You believe me?
Yeah.
Yeah.
Alright, so that's it for today,
I don't
okay?
believe anybody. Maybe the rest of them.
What if we created
How do you believe in
a
Bible?
YouTube channel?
You
You ever popped up like the video?